Alright guys, I know this is a bit early for a stream, but I really wanted to get started with D programming language again. Just woke up again. Took a 2-hour nap after my Greg Tech stream. This shit did not go very well, so we'll just go ahead and get started with this today. I think this is a good starting point for our D programming experience. Wow! Kate. Thank God for Kate. We love Kate here. Should I put it on that side? Is that what I did yesterday? Well, I should probably do what I did yesterday. Oh God. Let me resize this shit. Unfortunately, I won't be able to. Okay. Pop it out. Oh no. I just pulled up those tabs. This is completely borked. It's ruined. It's over. Anyway, I already got an idea going for what we're gonna do. Then we're gonna open up this as well. Pop that up there. I've already made warmup.d. Nice. Nice. Lastly, we're gonna go into here. We're gonna new folder. God damn it. Do we want to try something harder, or do we want to like continue on with our tasks from yesterday, the entire learning process? All right, here's our web browser. Okay, perfect. Just getting everything set up as well. This is joy. Joy to me. Oh, I found how to resize the shit. Perfect. We're gonna put it right there. Yeah. This is absolutely beautiful, guys. I clearly am a highly trained professional. Gordon's a highly trained professional. All right, this should be perfect for our D programming language. Create new folder, please. Warm up. Yeah, that works. That straight up works, guys. Guys. Throw that all in there. Boom, get that shit out of my way. We're also gonna open up the terminal like a complete noob right there. Perfect. Splendid. So we're all ready to go to do the next thing. So last time we got to the while loop. The next part of the while loop would be I guess reading the rest of this shit, because I didn't read it all yesterday. Here's the syntax of the while statement. While, blah, 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 blah. Figure that shit out. It's pretty easy. Easy shit. Very basic shit. Not too hard. What do we have here? While is useful when the value of a logical expression changes during execution of the program. To see this, let's write a program that takes the number 0 from the user as long as that number is 0 or greater. Remember, the initial value of values is 0. So what is this doing? So it takes the value of 0 when it's 0 or greater, and then while 0 is greater, then I guess it writes this. So while it equals 0 or greater, which this is always going to be 0 to start off, right? Please enter a number. And then if you were to enter, you could enter a negative because it's integer. So then you would write, let's say you wrote 10, it'd still be greater than 0. Then it will say, thank you for 10. And then right line exited loop. So if it, I wonder what it would do if I wrote something that's negative. Let's go ahead and create new text file. We'll call this, we'll just rename it to what it actually is, a .d file. Oh yes, jolly good. We'll call this while 2 .d. Perfect. Let's go ahead and get into it. Oh right, by the way, I gotta do one of these. Just to make it visible, so that way everybody can be satisfied with the text size. So that's the importing standard and standard input output. And then we have void main for our main body of code, semicolon. Actually, go back, don't do a semicolon. Do this, because this is going to be like a scope, basically. Pretty sure it's called a scope when you do that. Who knows? It doesn't matter what it's called if it works. And then we need to do our write, which then needs to be corresponding with read if. So like he does 2 spaces at the end. We'll try that out, see how that works. Pretty sure that will append an extra space there. We'll try it. All right, so first he declares his int number, or his variable, integer variable, as number, or declares that number is an integer variable, meaning it's going to be a 32-bit thingy, 32-bit thingy, and then does while. He does the while loop. You can technically put a space there. It appears he does that. However, I never put a space there. I just say put it right next to the fucking loop and then do it. Number greater than. Oh, you gotta do a space here though. Greater than or equal to 0. And then you do another scope for this. Boom. And then you do a tab indentation right. You write out what you want to write. Please enter a number. Hold on, let me just zoom out so it doesn't look shitty. Please enter a number, and then colon, double space. And then I haven't tried double space. Usually what I do is a space, colon, space, and it works fine. Semicolon, enter. Read F. Then we do this. Space. S. I forgot why that's important. I think it has something to do with. I don't know, but I remember that I don't know why the space there is important in this one. I've never actually put a space there, and it just seems to work. So I mean, this is like one of those languages which is really hard to screw shit up in. One of the few languages where it's really hard to screw shit up in. It's like Bash. Bash is for babies. D is for babies too. JavaScript will have you thinking that you don't even know what you're doing anymore. Even pros suck at JavaScript, bro. I swear. JavaScript, bro. It's fucking Satan's language. Straight up. Who came up with that shit? And then he puts in. Thank you for number. You know, I could just copy and paste, but that defeats the whole point of me trying to do this, because it helps me learn to do it and writing it out. Because then I'll be like, oh, I forgot this shit. Oops. Maybe I should figure my life out and actually put in the shit it wants me to put in. All right, your number. Thank you for number, and then your number is right here. Boom. And then go ahead and put that in, comma. And then if you wanted to put like more statements, you can put if statements. But so I guess that if it hits this, it will write line exit loop. But it would never hit this if you don't screw up the loop to break it. So we'll figure out how exactly this all works. But I'm pretty sure if I put a negative integer, it will probably break the loop and exit the loop. Exited loop. Bro, what if I learned about error code standardization? Like, I wonder if there's like a standardization for error codes and shit. Or if I could just fucking, when I make my own game, I'm gonna put whatever fucking error codes I want. Oh, your game is crashed with error code x36 times 452. Please go check the documentation in my 10,000 pages of documentation about why your game crashed. For exactly what this means. It'd be like overprogrammed, bro. Straight up overprogrammed. There's a reason for crash logs. So that way you don't have to have X number of 35 billion for your fucking error codes. Wow. Such gaming with that. But that will be when I make my game. DMD. We're in the right directory too, so it should be just DMD while 2.d, and if it has any errors, it will throw an exception while we're doing that. Perfect. Nothing's wrong. Perfect. And then we're gonna do dot slash while 2. Oh shit, my bad. I screwed this shit up. Oh, I screwed this shit up. So if I enter 69, it will just do that, and it'll be like, thank you for number 69. And if I put in negative, what if I put in 0? Thank you for number 0. What about something that's not a number, like A, B, C, D? Oh, and it causes that shit to come out. Because it's not a fucking number. It can't take a string and put it into a number slot. But what if I put in negative 12? Exit loop. Perfect. Exactly what happens when you do that. So then you could do. Oh shit! Fucking hell! I already screwed it up one time. 23. Hey, we're so back after my 2 hours of sleep. If I put in negative 23, it exits, which is very interesting. Very, very nice. Could have some interesting implications. Very good shit. So what's the next step? The continue statement starts the next iteration of the loop right away. Instead of executing the rest of the expressions of the block, let's modify the program above to be a little picky. Instead of thinking for any number, let's not accept 13. The following program does not think for 13, which this is probably something very useful. In this case, the continue statement makes the program go on from the beginning of the loop. All right, so I guess, we just inject the if in the middle here. Right. Enter, actually backspace. So you'd write if, and then you do your parameters for if. He puts a space there. I don't put a space there ever. We're gonna do, let's see, number equal 13. Oh, we're sorry, we're not accepting 13, bro. This shit's fucking comedic. I swear. We're not accepting number 13. It's special. For readability's sake, make this shit look good. Make it look nice. Don't make it look like that sloppy Java. Good God, I hate Java. Everything should be written in D from now on. It's the superior language. Clearly. Alright, so write ln boom, and then we'll go ahead and do sorry, capital sorry, not accepting D, or not D, not accepting 13 at not accepting that one. Oh, not accepting. He doesn't even say the name of the number. Bro, this is crazy. What does this guy have against 13? That's my lucky number right there. Excuse me. The fuck is D? What do you mean the fuck is D? It's the future, the language of the future. Truly. D is amazing. Somebody sent me, I don't even need this message in my life. Thank God. Anyway, D is amazing. It's like C, but with it's for like babies or some shit. Who knows? We're playing C on baby mode at this rate. We're not accepting that one. I think that's how he phrases it. Because I just want to copy his exact phrase. I could just copy and paste all this shit, but it beats the point. Bro, where are you from? Where am I from? It's a great question. If you want to know that, you just have to watch more of my videos. You'll find it out eventually. It's not like I hide it that well, but I wish I did. continue, semicolon, and then it should just work. Let's see. Doesn't that mean it's slower than C? If it's C with extra steps, probably. But it's different from C. It has its own compiler. If it was C with extra steps, that'd be shitty. You could go to D and read their documentation if you want to learn more, but I'm such a noob I couldn't tell you why it's better. D is a general purpose programming language with static typing systems, system level access, and C-like syntax. With the D programming language, write fast, read fast, and run fast. Fast code fast, 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 more fast. I'm adding the extra fast because they seem to like the word fast. That's their spiel apparently, but I could sell that spiel for them. 25 reasons why you should code with the D programming language. And it's just 25 AI generated chat GPT reasons. It'll be like the 10 reasons why you should use Linux video. Good God. Absolute cancer that is. Let me just check that there's no caught myself. I knew there would be an error somewhere in there. I hope their little spiel explained it. Oh, I don't understand shit. Might be good. Yeah, I don't know. I mean, I'm gonna code a game in it eventually. We're just building up my skills, and then we'll see if I can become a programmer or a programmer. Bro, which is the language I start with from as a beginner? Someone suggests me Python. What's your thought on this? Well, honestly, Python's easy. Don't ask me that. I'm the wrong person to ask. Okay, I have the least amount of experience with programming. I'd say Python's the easiest thing in my experience, but like my experience is using other people's shit and it just works. This is making my own shit with D. I feel like D's pretty easy, but D is also great for beginners. I feel like the person who recommended this to me really knows what they're talking about with D. Even programs in D regularly. But you can always just, I guess, program in D alongside me, or like if you want to learn an actual practical language, I mean, there's C, but I mean, it might be harder to learn. I mean, the whole point of this is kind of like, I don't know. But yeah, he's saying definitely Python. Like, Python's not bad. I couldn't really tell you a good reason why I wouldn't use Python for something. It's got a lot of good, easy shit. If you want faster Python, use Lua. I've tried Lua. I think it's not for me. Lua's too picky. Lua's too picky. I hate Lua. I've had bad experiences with Lua. I'm not going to talk about it. Oh, did I close my fucking terminal console? Oh. I must have closed my console. That's why I'm losing my mind here, trying to find my console. But dmd while.d while2.d. That will compile, and then we'll go ahead and you're gonna make your own renderer in this. I was gonna use OpenGL, or try to use OpenGL. I've been told you can allegedly use some shit from C, from somebody who knows more than I do. So I've been told it's really easy to implement C code with D, but I'm no expert, no master, so we'll probably end up having to make 500 bridges that we need to burn once we get there. So /while2. So now we can enter a number. We can enter 13. It should just skip number 13. Yep, 13. If we put in 23, thank you for your number 123. Negative 13 will exit. Still, it wouldn't even need to be 13. I also don't like Lua, but it is used in open computers, so I have to deal with it. That's fair. You could also just get like different architectures in open computers, like 6502 architecture. If you don't want to use that, always just use one of those, or make your own architecture. Well, learning is a process. Yeah. You gotta go in steps, like the crawl, walk, run is what it's called, bro. Anyway, back to this page. Alright, we can define the behavior of the program that takes numbers as long as they are... Alright, but anyway, this should make sense. Oh, continue works for do while, for, and for each statements as well. Okay, that's good. So do while would be interesting. Very interesting. Is it just like a while statement, but like with a do at the beginning? Like, do this while that? I'm guessing it's probably like that. Very easy to read then, if this is the case. Unless that has some kind of other meaning that I don't know. Ooh, sometimes it becomes obvious that there is no need to stay in a while loop for any longer. Break allows the program to exit the loop the right way. The following program exits the loop as soon as it finds a special number. Alright, so then you do read F, then if, and then you add in your break. So, instead of, we could put in his if 42, and then put that in our loop, so... We'll go ahead and enter and backspace. Fucking hell. Almost screwed this shit up. I'm gonna do future. I'm figuring out, but I have little interest in C#. That's why I'm asking. Do while is like only check a statement once the program is finished one time. Okay. I have no idea what that means, but the book will explain it to me. So you only check a statement once the program has finished one time. So is that just like a loop, but like weird? It's like a weird loop? Like, am I stupid? I think I'm stupid. I think that's like the most simplest sounding shit of all time. You make it sound so simple, but yet that does not. Ah, this is bothering me now. I need to put spaces here. I don't think I ever put spaces before then. Technically, you don't even need spaces, I guess. I guess it's for readability. But do I really care about people's readability, except for my own? I should probably care more about readability. Alright, so you do write ln, and then you put in your break. Loop broken do this broken, and then you would go into your next semicolon, enter, and then you do break and semicolon, which break doesn't even need any parameters, so it makes it very easy. In a normal loop, while loop, you do check if something is true at first. But in a do while loop, once the module is finished, it will... Oh, so it's just a while loop, but it checks the condition afterwards. So then if it... Oh, okay, that makes sense. So then it would go back to the start if it's not true after the statement. So that means that, like... That's pretty useful to know. Do while is probably going to be one of those that I use a lot. Do... Wait, do you already know D? Or are you just doing C? Hope that's easier to... No, I think I understand now. So it checks the actual statement at the end then. Very interesting. Control S. Hit this. DMD while2.d and then /while. Then we can enter our number. Let's go ahead and enter 13 just to check that that works. 12. Thank you for number 12. We're not going to do negative, we're going to do 42 now to loop broken, exited loop. Oh, so just exit the loop anyway. Found it. Found the meaning of life finally. Good God. Took it that long. Alright, so an unconditional loop. Sometimes the logical... Okay, we'll have to go ahead and put this into our while loops. So we'll put this into whiles. Create a new text document, text file. We'll call this one, I don't know D, but I have some decent enough to understand the concept of do while. Okay. It's just like you had formatted it to where it's like almost Almost looks like what I'd expect to see in this book. But I guess I'm just not super experienced. Unconditional loop. Oh god, that's gonna be a pain. Unconditional loop. Got no clue what the hell is happening. You're just here to listen in to the joy of decoding. You don't need to know what's going on. You just need to watch the programming happen. You are surprisingly well managed. Yeah, I could just make like 30 of these, but then I'd get fucking confused. I have to be well managed, or I'm gonna lose my mind and be like, where's this file at? It's a discipline. It takes a lot of effort to actually want to learn shit. Compared to your HBM world, yeah. Bro, HBM world, we had to have Dosto come in and sort it every day. Bro, it was madness. He didn't even show up half the time, but that's fine. Dosto needs to do medical shit, so we don't need to worry about that. Import standard d.standard IO. So basically what this line says is that it's importing this library, which is just built into D. Then you would do main void with the void is or actually no, backwards. Void main is the function, and then this is your parameters for that. And then no one did it as good as Daniel though. Daniel, man, Daniel's insane, bro. Daniel's an absolute madman. We don't dare talk about Daniel. And then this is all set up. So we have our parameters here, and then we have our scope here. And then this, we don't ask why this is here. We just know that this is here for a reason or some shit. And then this obviously you need to add in the library. I'm trying to explain it to make it easier for people who don't know what's going on. Because I've gotten pretty far in the book, and if you haven't seen last stream, it might be kind of confusing to be like, standard input output lib, I think. Yeah. Oh, so like I could probably import OS like in Python. I've seen that done in is that a thing you can do in Python actually? You know, I've seen my AI do it in Python, but my AI is fucking stupid. My AI will just do whatever it wants and be like, "Oh wow." So, what's this? All right. I'm going to just copy and paste this one. We're gonna go ahead and paste it in there. Oh god. Gordon, no. Zoom out a little bit. Actually, it'd be better if I just make it on my own and then I figure it out. The following program prints a menu in an unconditional loop. Okay. It'd be better because if I did it on my own, it'd be better. Alright, so we'll do 0. 0 is Red Bull. 2 is Monster. If you replace it with int, then you will have to write return 0 at the end. At least that's the case in C. And then we'll put in 3 is nothing. Oh shit. 3 we could just put event horizon. Good god, event horizon. Never mind, event horizon. This is just a fucking, that's a HBM joke of all time. Canned black hole right there, bro. Straight up. Alright, so then we would do the if statements, which he's got like a ton of them. So you do int choice. I've never done oh wait, void is there so that the function main doesn't return any value. Oh, so what if I took void out, then it would return value? Oh, okay, so void just means it doesn't return value. So if I voided right, it wouldn't return any value. But I don't know how that fucking works. It's like magic. int choice, this sets it to 0, then that creates an integer variable called choice, which you can set using choice equals 0 or whatever. But we're gonna just say, we're gonna have the user set that using readf, and then it will go like this. And then we do space, % and s. This method of learning coding is too rigid in my opinion, but it depends on the person. Yeah, I suck at learning shit. I've tried 100 times and I could never get it, but doing it like this, I'm actually kind of starting to understand shit. See, I'll do this and I'll be like, oh, what happens if I do that to the program? What happens if I do this to the program? And see all the different ways it works and shit. We're just gonna... We haven't gotten to any of those today. Alright, so... and choice. So the and basically says that it goes into choice, like it's gonna set choice with readf. It's kind of like if you do something in bash. I forgot. So I'm not even gonna explain it. Not even explain what I do in bash, but I've done it before in bash. Choice equals, and then you take your value, then you have 0. It will do whatever's in this scope. So like if I wanted alright, so right line, and then we do that. Red Bull. Perfect. Semicolon at the end. What I would recommend for beginners is to learn the basics first and then make a program on your own with no help. Yeah, I'm still learning the basics, man. This is literally the basics right here. Basics right here. But that's, I guess it's for other people. I mean, you could always code along with me and be like, but I don't think that's a good way to learn, honestly. If you were to watch me program and program along with me, I think that'd be a shitty way to learn. I mean, I guess if it helps you like get into coding, and then that's always cool. That's always amazing. So it looks like if choice equals later, event horizon. We'll do that for event horizon. Gordon, we're doomed. Oh, what the fuck am I doing? Alright, so then we can do if, and then we put in our parameter, we put in choice equals 2, and then we put in our next thing. The reason you put an and is so that the compiler knows that it's an input line. Oh, okay. That makes more sense than what I was thinking, but... I was thinking it was more like a pipe, kinda. Like a pipe, you know what a pipe does in bash? Like, pipe the output of this command into that command, but I had no idea. Right, ln, then we would do this, put some parameters on there. Oh, never mind. But put some parameter. Hold on, that's bad. That's bad. Don't do that. Write that. Right line, parameter. You chose monster. Then we do semicolon. Coding is such a great activity, but too bad AI has made it completely non-profitable. What do you mean AI has made it completely non-profitable? AI sucks at coding. I've never had my AI code out any shit that's good. Unless there's actually AIs that can do that really well, but my AI is kind of shitty anyway. It only has 8 billion parameters. If choice equals 3, then we're gonna do oh. we can do right ln, and then we do the next thing, function, no, parameters, quotation marks, Gordon, we're doomed. Then semicolon, and then we put in our break, semicolon, and then most of AIs already has Git. Most of the AIs already have Git support. I think programming is not really. Meh. I feel like I don't know, but I kind of got this feeling that after AI goes away, which I have a feeling it's gonna go away eventually. You'll see that programming is kind of gonna be really important. There's gonna be like a demand for programmers after AI goes away. Because AI is definitely not here to stay. And if it is here to stay, then it's going to just cost us money at the end of the day. Because it's too expensive to run AI, and they're not generating much profit off of that. Data centers that are like needing to have their own power plants and shit just to reduce their energy cost. Shit like that. That's not gonna really work that well. I don't think. I think that would probably, oh, what the fuck is this? He has else if statements. So you would do, else if, and we could just reformat how I did this. Oh. Okay, well, we'll be able to fix this. It won't be hard. Choice equals 2, and of course, we should definitely make this look better. So we'll do that, and then we'll do another else if. Yeah, I got a feeling it will go away. I don't think it's gonna be here to stay. And if it is here to stay, who fucking cares anyway? Oh god. But I got a feeling that it's probably not gonna stay because of that. It's too expensive to do that shit. Your AI stole gallons of water from poor African kids' fish. Bro, my AI ran locally, but whoever developed it might have done that. I'm gonna be honest. Whoever made the AI probably ran that shit and stole billions of gallons of water. Straight up. Probably has a massive data center that they're working at. Like maybe like a college somewhere, bro. I bet colleges have AI data centers in them where the students work on AI or some shit. This type of example would be better, or better of a case example. I have no idea what a case example is. You will see why later? Okay. What am I thinking of? Okay, so that needs to be after the break. We're gonna go ahead and put a space here. I hope I didn't do shit wrong. I got a feeling I might have screwed some shit up in here. Else. But I think all my syntax is good. I think it's just the order of operations. I think putting that in the break in that position might actually be pretty bad. Tab right ln something. Oh yeah, right ln, and then we'll just put not an option. Not an option. Try again. Perfect. This is good. Dot Control S, and then run the console again. Just hit up 2 times. DMD.o. Excuse me. What? Oh shit. Yeah, my bad. You know what? We're gonna have to write out this whole thing. Oh no. Unconditional loop. .d. Oh god. Some shit's screwed up in here. Semicolon needs to go there. Check for extra semicolons that are missing. Semicolon there. Should just work now. Okay, it looks like oh, it's expecting an else if somewhere. Let's check everything. Let's just go through and make sure everything's right. Else is perfect. It needs an extra bracket right here. Oh, good God. That's terrible, actually. This is shitty. There. That looks better, I suppose. I hope that looks better. I think I screwed up the formatting, but that's fine. The formatting doesn't matter. As long as the rules are there, it should work. Alright, let's try it again. Unmatched closing brace. That's there. That's there. This is nowhere. Okay, so I fixed it, but then I added an extra bug. Well, at least the compiler helps catch this shit. Break. Break is not inside a loop or a switch. Okay, so if I move this shit around, copy, then paste it right here, cut this shit, and then paste it there. Alright, so that should help. D needs more love? Yeah, truly. D is an amazing language. It's probably the easy. If I can learn it, then it's amazing. Paste. And then, of course, 3 is going to be here, and then 0 is going to be here. I don't know how that's going to work. Or actually, I could just change this around and say that it's 0 now. It goes 3, 2, 0. Wait, what the fuck? Bro, what kind of menu is this shit? 3, 2, 0, where's 1 at? God damn, I've screwed some shit up here. This is some gigabrain moment right here. Absolutely amazing. Nobody caught this shit sooner. This is absolutely amazing. Break is not inside a loop. Oh, right. Yeah, that also makes sense because I didn't have a while true statement. Oh, shit. What did I do? Oh, God. Oh, God. So we need to put a while true loop in here because I forgot that part, apparently. So, backspace, enter. That, I should have caught that a lot sooner, but I didn't. While, and then it will just always run. So it will be always true pretty much. If it's while true and there's nothing to change true to false, it will just stay true. And then put in our brackets. Perfect. And then, of course, going to add a tab in front of everything just to make it look better. So it's a little bit more legible. Just tab everything here. Perfect. There we go. That's just such a rookie mistake. I didn't even notice it. Yeah, that's like my brain shut off for like too long there, and then DMD unconditional loop finally compiles, and then DMD, and then we'll have to type out that horrible ass name again. Unconditional oop. Oh shit. Ew. Dot slash. Yeah, I'm making all kinds of mistakes right now. Must be a little tired or some shit. Excuses. Red Bull Monster or Event Horizon? Event Horizon. Gordon, we're doomed. Unconditional loop. 2. Is this unconditional? I don't know what unconditional is, but... Alright, so this... Okay. Sometimes logical expression is intentionally made a constant true. Oh, right. So, like, because you can't change it, it's unconditional. Cool, next thing. Exercises. The following program is designed to stay in a loop as long as the input is 3, but there is a bug. It doesn't ask for any input. Let's see. While number equals 3. Right. I think putting the int choice in a loop might cause problems. Not for this scale, but later def make sure not to do that. Got it. Because it will just keep it will keep setting yeah, it makes sense. Because it keeps setting your int to 0. or trying to redo the int, the integer, the variable. We'll keep trying to do that shit. That's why that would be a bad idea. Keep trying to, whatever the fucking words are. Don't even know. I just know declaring int number over and over again every single time would probably not be a great idea. Fix the bug. The program should stay in the loop as long as the input is 3. Alright, so while number equals 3, readf %s. So, I mean, you could just put a break if it doesn't equal 3. This is a nice exercise. I actually have no idea what is wrong with this, besides the following program is designed. But there's a bug, it doesn't ask for any input. It doesn't ask for any input, but it has an input here. This is like your input, right? Let's see. Let's see if you can do it. Yeah, let's go ahead and let's get it loaded into here, because I think it'd be easier to mess around with the exercise in here, and then we'll put this in with while loop. Create new text file. We'll call this exercise.d, and then we'll close this. Close that shit. Put that in there. Perfect. Alright, let's get started. We're just gonna copy and paste all of that shit in there. We don't need to worry about all that. I know how to type that shit out. We're gonna go ahead and Control S. We're gonna try to compile it first. Compiler usually catches errors. DMD exercise.d. Okay, doesn't catch any errors, which is interesting. /exercise.d. Oh, don't do the .b part, just do that. Okay, it doesn't even run, it just exits the program instantly. That means, let's see. So while number equal, oh, that's fucking easy. Look at that shit. Because the number never equaled 3 to begin with, it wouldn't run. This thing doesn't have it's just a normal skill issue when you write it normally. Oh, shit. Hold on. I didn't do that fucking right. Testing if it equals in the declaration of variable. Control Q. Number 3, 2. See that? That's what's wrong with it. Wow. That was really easy. Alright. What's up next? Make the computer help Anna and Bill play a game. First, the computer should take a number from Anna in the range of 1 to 10. Then the program should not accept any other number. It should ask again. I don't think the writer of this tutorial wanted that fix, but they have not explained the do-while loops, I guess. No, I think that's exactly what they wanted. Should stay in the loop as long as the input equals 3. Because the input doesn't equal 3 to begin with. It's like testing if you can catch that it's not actually running correctly, I feel like. I feel like that's exactly what he wanted to point out, is that if you don't declare your variable as 3 beforehand, and then go into your... I mean, technically neither way is wrong, either. Like, it would just be impressive if you did a do-while before you even mentioned do-while. I don't even know if... Well, actually, there is do-while, so you already mentioned that. Pretty much just is C with extra steps. We'll just throw this into here. Text file. What is this one? Oh, we'll just call it arithmetic. Yes. arithmetic. .d. That exercise is interesting, I guess. The ANA one. Yeah, I don't know. Don't know if I want to try that shit out right now. If we ever need to do that, we could do it later. All you need is a if statement for the ANA one. Well, yeah, you would need like an if, and then you'd need to have 2 to check if it's greater than or less than a certain number, right? Like, and then have that number stored in the variable somehow, right? Something like that. It'd be pretty easy to do. I don't think it'd be pretty hard. Honestly, I think it'd be one of the easier things to do. Alright, so integers and arithmetic operations. We have seen that if and while statements allow programs to make decisions. I think yeah, probably. Something like that. I mean, if you wanted to try it out, you could do it, but I'm probably not. Here's like the operators, basically addition stuff. So you can do addition. This is the most important thing I feel like that I've learned so far is the addition stuff. I mean, there's a lot of other important shit, but if you can't do addition, then that defeats the whole purpose of a calculating or computer and all that. If you can't add shit, this increments by 1, decrements by 1. The result of 2 values, first plus second. Result of subtracting the second from the first. If you do x below and x above equals. Yeah. Well, you wouldn't do and. You have to do and, like 2 pound signs. You know what I mean? But yeah, I guess that would work. Pretty sure you would put 2 pound signs for this. Percent dividing the remainder of the dividing first, which is the remainder means what's left over. The result of raising first to the power of the second, multiplying the first by itself second times. Oh, okay, so if you put like that amount. Most of those operators have counterparts with that have an equal sign attached, like plus equals, minus equals, times equals, divide equals. Basically, that means that if you have a variable plus equals, it will just automatically add and subtract during a loop. We don't even need to read that shit. I know what that is. Instead of doing variable equals variable plus 10, you could just do variable equals plus 10. It will do it for you. Would also like to summarize 2 important concepts here before elaborating on them below. Overflow, not all values can fit in a given variable type. If the variable is too big for the variable, we say that the variable overflows. For example, the value of the type ubyte can have values only in the range of 0 to 255. So when assigned to 260, the variable overflows, wraps around, and its value becomes 4. Some other languages like C and C++ overflow for signed types is legal in D. What does that mean? So it's allowed? Unlike, oh, okay, so, and I don't know the difference, but I guess that means that you could have overflow for a negative integer or a positive integer, I guess. Who knows? Truncation. Integer value types can have values with fractional parts. For example, the value of the expression int 3 out of 2 is 1, not 1.5. Okay. Integer types can have fractional parts. Okay, cool. So because you can't take a float, you probably have to have the integer part, like a fraction part. All right. Unfortunately, things are not as simple with arithmetic operations in computers. We don't understand how values are stored in a computer, we may be surprised to see that a company's debt is existing debt of 3 billion, or when a box of ice cream serves 4 kids, may claim that 2 boxes would serve sufficient or would be sufficient for 11 kids. Okay, programmers must understand how integers are stored in computers. Yeah. Okay, integer types, and then it has the different integer types. So if you have a byte, you have 8 bits. You have a U byte, it's 8 bits. And then also these have to be like binary too, right? So then you have to account for binary. Base 2 is a lot different from base 10, obviously. So like just having the number 8 in bits is a lot different because it's just ones and zeros for that. Short, U short, int, U int, long, and U long, which is 8, 16, 32, and 64. But U int and U long can be longer. They have to be positive though. So they have a lot greater range of value, but they can only be positive and never be negative. So I think for the most part, from what I've been told, we're probably going to use long and int. Although I could see usage for like a short or a byte. But of course, the number of bits means you can only have that many number of bits worth of values. So if you have 8 bits, then you could just create a table and be like, well, how many values how much can 8 times, or 8 to the power, or, no, I don't even know. How much does 8 to the whatever give you? And then figure that shit out. 8 times something. Who knows? Although they're equal to the U at the beginning of the type. I'm sure he'll explain it later in the book too. I think that'd be good. If he does explain it to me, that'd be nice. The U at the beginning of the type names stands for unsigned and indicates such types have values less than 0, or cannot have values less than 0. Although they are equal to 0, 0L, and 0LU are manifest constraints. I was watching some free BS or D videos. Now I see a cyberbullying station is fired up again. Nice. That's good. Oh wait, you're the person who came up with the cyberbullying station name. Yeah, I'm planning on doing a lot of this today. A lot of deprogramming. I've been enjoying deprogramming more than I enjoy video games, which is I don't know, maybe that's a sign I need to switch over to deprogramming permanently. Deprogramming, the greatest language. Who knows why it didn't stick? Signed and unsigned variables are pretty high level, I think. Yeah, it's me again. As there aren't many concepts that can be represented by just 2 states. Oh wait. In today's computer systems, the smallest information is called a bit. The physical level of a bit is represented by electrical signals at certain points on this. Yeah, we understand this, but what is this? As a result, a bit can have 1 of 2 values. If we consider 2 bits together, the total information we can have in values possible, 0 or 1. Individually, there are 4 possible states, assuming that. So in 2 bits, you could have 4 states. Oh, so then in 8 bits, you could have something else. You randomly got suggested to me and actually enjoying your content, lol. That's good. My Linux comedy video will come out soon. It will be amazing. I think it might have already came out. Who knows? I also am trying to sell RAM t-shirts right now. RAM t-shirts. DDR4 t-shirts, guys. If you wear this t-shirt, you will get robbed instantly. Watch out. DDR4 t-shirts. Bro. DDR4 t-shirts is cursed right now. In this economy, gotta watch out with that DDR4 t-shirt. The value, what is this? Let's add 1 more bit to see this effect better. 3 bits can be 8 in different states. 0, okay, as can be seen. Each added bit doubles the total number of states. I want some RAM. I wish I had more RAM. I went to Best Buy and it costed like I was looking at it, and it would cost me like, for an upgrade, it would cost like $200. You got loads of old RAM sticks in your backyard. Good luck on that. And good luck on selling the RAM t-shirt. Bro, the RAM t-shirt. RAM t-shirt's absolutely insane. It's absolute madness. The RAM t-shirt. Now I have to pull it up. Bro, the Ram t-shirt goes hard. Ram is in fashion with John Badass. That's my real name. John Badass. Wow. You have 16.5 gigabytes of DDR4. This is truly a Giga Chad t-shirt. 7 are in use. You have 8 gigabytes of swap. 32 gigabytes committed. You're 32 gigabytes committed to work. Wow. Wear it to work, wear it on a date. You're 32 gigabytes committed to that relationship. It's I always come up with these dumb ideas for products, but ain't no way. I mean, look, I also have some other questionable pictures and shit here that we could put. Like, what about a Wonix t-shirt, right? I don't really want to sell Wonix merch though yet. But we have meth.png. I'll let you guys read this for a second. We could put that on a t-shirt, or 5 reasons to be gay in 2019. You need to make different types of shirts with different types of loads. So when you're feeling a bit down, you put on the other shirt. Maybe. Or I could do CPU performance. While I was trying to install Rock M yesterday, I discovered that it can max out all of my CPU cores for at least 10 minutes straight. And I have an image of that, but it's like that meme where the guy takes a photo of the screen, because I can't take pictures of the screen. I could just do something not that. Could just come up with another genius idea. Or this one, the you should switch to Linux t-shirt, which has it all. What are 5 reasons to become gay in 2019? Bruh. Peak performance? Yeah. Dual GPU club. That'd be the next one. We can construct the following table by adding more bits. So a byte has... Finally, it gets to the point and tells me a byte has 256 of those. Which, by the way, we're going to go to D language tools to just get back into it. I was actually also getting us set up with shit for B language and APL language, which is the A language. The A programming language. And there's A plus language. But A plus language, you need XEMAC. Some shit like that. And it doesn't exist anymore, unfortunately. At least I can't get my hands on it. So I can't do A plus coding. But I can probably try to get A programming language. But I was looking at A programming language, and I was like, bro, this is a fucking alien programming language. So, also, like I said, with the unsigned bits, these go really, really, really high. Like, if you have unsigned, it means it can go slightly higher than the signed version. So there you go. That's the numbers that you can have. So technically, if I opened up a spreadsheet right now, I bet I could probably overflow it with a massive ass number like this. Trying to calculate with a number that huge. I skipped many rows in the table and indicated the signed and unsigned versions of D types that have the same number of bits on the same row. Alright, choosing a type. D has no 3-bit type, but such a hypothetical type could only have 8 distinct values. It could only represent concepts such as the value of a die or a week stay number. On the other hand, uint is a very large type. It cannot represent the concept of an ID number for each. As its maximum value is less than the world. Oh, okay, that makes sense. World population of 7 billion. This is why D is so good then. Because of the types. You can choose your types. Honestly, like, I feel like it's kind of a case of choose what you need for each situation. The type of variable. Like, if you need to use an integer for something, then use that one because it fits your sizing needs. It's like choosing the right pair of shoes almost. If you wear size 13, you wouldn't wear size 14 to go do some shit. Well, actually, you could wear size 14, but would you really want to? Probably not. I mean, it's not like it would make a difference if it's one size, but if it's size 27, I mean, I don't think there is a size 27 in US sizes, but if it's fucking ridiculous, then what's the point? Overflow, the fact, then obviously that's, if you have too many, then you can overflow. So like if you have like 9 and you have if you have 257 and you put it into a byte, then yeah, that's not great. Oh, but can you choose bits, like bitwise? No, you only have byte, U-bit, or U-byte, and byte. Unsigned byte can go up to 255. It's C for more specific case scenarios. I haven't even. I'll try out C next. I feel like C is a good language to try out next because people use that shit anyway, and it will be easy to learn. Since integers cannot have values with fractional parts, they lose the part after the decimal point. For example, assembling a box of ice cream that serves 4 kids, although 11 kids would actually need 2.75 boxes, the fractional part of the value cannot be stored in an integer type, so the value becomes 2. I will show you limited techniques to help reduce the risk of overflow and truncation later. So truncation would mean so it would just not put out 2 points, it would just put 2. It unlocks C# and C++. Yeah, those were always really confusing. I tried making a horror game one time, and that one thing, I already understand how to increment. We're gonna skip that because you can just do a loop. I already have a program that does that, I believe. That should be we did it yesterday in standard. Was it if while? It was our first while loop, so it should be just this one. Open terminal here. Wait, what? Fucking hell. Run in console and look at this shit. It just prints out that. Doesn't do it forever. It just prints out that. Pretty cool. Pretty cool, right? Yep. Pretty dang cool. Oh shit. Nice. All right, let's go down. All right, so then these are okay. If the result of the increment operation is greater than the maximum value of that type, the result overflows and becomes minimum value. We can see that this effect by incrementing a variable that initially has the value of int max. Okay. Also, what does this do? Minimum integer value, maximum integer value, and then you would do, we've already seen how to do that shit before. Alright, then you would do this stuff. You would do plus number, and then you'd increment it, it would overflow, and it would just add, wait, what does this do? The value becomes int min after the increment. Oh. Very interesting. So you increment it and it becomes integer min, the minimum integer. Decrement. This operator is very similar to the increment. The difference is the value is decreased by 1. Cool. So if you do this, this operator is used with 2 expressions and adds their values. Import standard Standard input output. Okay, what is this? It's operator. Okay, addition, very basic shit. I think I know how to do addition. I think I know a little bit about addition. Wow. We could do 250 sided dice. Subtraction. This operator is used with two expressions and gives the difference between the first and the second. Interesting. It is again surprising if the actual result is less than 0 and is stored in unsigned type. Just subtraction again. Unless there's more to this. Wait, hold on. Oh, yeah, because if you do an unsigned type, you can't have a negative, of course. Multiplication. Multiply number 1 by number 2. 6 and 7 makes 42. Oh god, that joke is unreal now. I'm sure it wasn't real when this was written, but now it's unreal. God damn. Oh shit, I get why your friend said to learn this. Why? What exactly is interesting about it? I mean, it's really easy for me to learn, but like still, what the fuck is interesting with this shit? Like you keep going, oh, I realize this, but well, that's not what you're doing. I mean, but like, I'm sorry. I should just listen. I shouldn't try to make a joke. Reminder modulus. This variable divides the first expression by the second expression and produces the remainder of the division. So if you divide 10 by 6, you get 4. This is a common application of the operator to determine whether their value is odd or even. Since the remainder of dividing an even number by 2 is always 0, comparing the result against 0 is sufficient to make that distinction. Interesting. Power. 3 by the power of 4 is 81. Now you can joke. But I'm curious. Why should I? Why did my friend say to learn this though? Can you explain? Oh. Need more. Don't know. Need to hold back. That just did not feel right. You know what I mean? It was not right. See if it's Daniel, it's okay. I mean, it's just getting too into character sometimes. Too into character. Bro, I'm out of character right now. Straight up, no, less jokes and more programming. All work all day, no time for play today. We're here to program for 600 years. Yep, gonna program for the entire day. Negation converts the value of the expression from a negative to a positive or positive to a negative. Very interesting. Very useful. Plus sign has no effect and exists only for symmetry with the negation operator. Positives values stay positive and negatives stay negative. This language has such an interesting architecture. So it's like, it is very different from C. Import, oh, what is this? Post increment. Unless there's a strong reason not to, always use a regular increment operator, which is always called the pre-increment operator. Instead of some other languages which have vague type of memory management, this goes really deep into that. Yeah, it's also, if you look at the page, the home page for D, in documentation, no, maybe it's in learn. Multi-threading? Like there's multi-threading in this shit? It's compiled, so obviously if it's compiled, I feel like it goes into that, like it becomes assembly, and they just set it up more for like the usages that, you know, Anyway, that it's got more power to it, more oomph. But obviously, it never took off because, well, Microsoft makes C, and Microsoft, everybody loves Microsoft, right? That means everybody's gotta like C. This is C's better brother, who doesn't have all the flaws. This language has definitely been used to create an OS. Do you think we could make an operating system? That's why it's so interesting. We'll create the Fishdom D. D-Lang operating. I'm curious now. It supports bare metal programming, enabling direct hardware access. Bro. Genetically modified younger brother? Bro, this is crazy. Direct hardware access? Efficient system level code similar to C and C++. Unlike interpreted languages or those requiring a virtual machine, decompiles directly into native code and interface with the operating system just like C does. Several projects demonstrates D's viability for OS development. PowerNex, a full operating system written in D, aiming to cover the next generation of hardware. It uses a custom build system and cross-compilation tools with a kernel built from the ground up in D. Trust me, you do not want to go down the operating system rabbit hole. The D kernel Trinix and Hydrogen. Other examples of D-based kernels and OS prototypes showing that D can be used for real-world OS development. D's garbage collect. So we can see this is what I like though, is that you can interface directly with the shit on the system. Like if you can mess with like hard drives, things like that. Obviously, very powerful language, especially like how C is a very powerful language, but C is more widely used. Obviously, this will be perfect for building a video game on. While D does not have a VM, its runtime D runtime is minimal and can be customized or stripped down for kernel use with tools like LDC, LLVM, decompiler. Let's go ahead and look up PowerNex. I'm kind of curious now. PowerNex. I wonder if it's like Windows but better. PowerNex. Oh, it's not even a thing. PowerNex OS. An operating system written in D. Wow, look at this shit. A 64-bit processor, at least 512. Search if there is a rendering engine for D. Alright. You think I'm ready to actually get started with a video game at this point? I think we could probably get started with that. Well, here's the thing though. You can pull in from like C with D. You don't necessarily need to have D-Lang rendering engine. Cross-platform D-Lang game engine. It's already a language. I don't want to use their code. I want to make my own, though. Obviously, I don't need all their... No way you're ready? Alright. Thank you. You can use OpenGL with D. You'd integrate D bindings from OpenGL with windowed library like SDL2 or GLFW. The most common approach uses derelict GL3 for OpenGL bindings and derelict SDL2 derelict GLFW3 for window management. No amount of pure math you need to make a game from scratch. The amount of pure math you need to make a game from scratch is disgusting. We're not going to do any kind of rendering, but we're going to just try to use OpenGL if we can. You need more math than programming skill for games? Yeah. Because the engine itself, if you were to build the renderer, you're doomed. You need to know trigonometry. 3D rendering requires trigonometry, but derelict GL3. A dynamic binding for OpenGL that loads functions at runtime. To load... Oh, okay. Then you'd have to import derelict GL3.load. Then you need to know how to use it. But at least we have this available for later. Very interesting. Oh no, Tommel, please get back here. TOML. Ew. I need my Tommel. We'll need that later. Oh, trust me, a lot more than trig is required. Like demon trig, bro. Demon trig. But for now, focus on learning the basics. Alright. Operator precedence. Operators we've discussed have been all the way down. Detecting overflow. Although it uses functions and ref parameters, which we have not covered yet, I would like to mention here that the core.checkedInt module contains arithmetic functions that detect overflow. Instead of operators like plus and minus, this module uses functions, adds, and addu, or for signed and unsigned operation. Mols and molu for multiply and multiply signed, multiply unsigned, subs, subtract, okay, and negative for negation. For example, assuming that and this is really like a machine code. I'm gonna be honest. This is also kind of like machine code. Wonder if this is object oriented, but probably not. This is really like machine code. It's really weird. Like you have, so in a machine you have like XOR, NOR, and like shit like that. But if you think about it, this is just like XOR and NOR, but with like you put in a couple of lines and then boom. Oh, well, there's our shit. That's how we figure shit out. Obviously, you need to be able to do if and math, which is what makes a machine do shit that's pretty fucking cool. Like, if statements and math are two things, because that's your arithmetic logic unit in all of that, is being able to do a test a statement to see if it is this and that, and then, of course, like, doing math, too, to test math, and then doing them both at the same time. Multi-threading is pretty interesting too. That's something I really want to mess around with too. Multi-threading. Not even multi-threading though. I want to mess around with GPUs. I have 2 GPUs and I want to use them for something. Probably going to make my own game that runs on a GPU at some point. Good God. Optimization is the hardest part. Yeah, that's... See, I have programmed before, but I've programmed on easy mode using Game Maker Studio. And when I had my old PC, way back when with the fucking DDR1 bullshit, I'm pretty sure it was DDR1. It was a laptop, who knows. That shit was fucking ancient. Bro, I spent years using that shit, and it somehow still was running. It existed for like 14 years, some shit like that. Absolute insanity. But, yeah. That shit was unoptimized and it ran like slop. Detecting overflow, although it uses functions and reference parameters, which we have not covered yet, I would like to mention here that the core checked int module contains arithmetic functions that detect overflow. Okay, we've already discussed that. All right, and then of course, okay, so then you would import your core.checkedInt, and then you can use those, right? You do int.max. All right, let's see what he has to say. Let's cause an overflow for test purposes. Int.max -1 int b. This variable will become true if the addition operation inside the adds function overflows. Has overflowed. Then if has overflowed, this will result in a true statement. Okay, that's useful to know. So then writes the so add signed would write it to the statement has overflowed, and if it has overflowed, then it will put it into the result. We must not use result because it has overflowed. We can use result. I don't know what the point of that is, but there's also the standard experimental checked int module, which defines the checked template, but both its usage and yeah. Like I can only imagine not having something like this, because I don't know shit. Like if you couldn't just be like, oh, it's overflowed, and so you could reference that later and be like, well, it doesn't care if it overflows normally. So if we have to detect that it overflows for it, and then be like, oh shit, it's overflowed. Crash the game or some shit. That'll be when we make the game someday. Preventing overflow. If the result of an operation cannot fit in the type of the result, then there is nothing that can be done. Sometimes, although the ultimate result would fit in a certain type. Preventing overflow. Oh, okay. So like number of trees needed. That's really good because the check if something has overflowed is like operating infinity. Yeah. Always results in an error. Alright, so not to mention it is... Wonder how the devs made that. That's an insane question to ask because I have no idea. I'm not even sure if they have any idea how they made that shit. They probably just plopped it in there and it just worked or some shit. I don't even know, man. It's insane. It's absolute madness, man. The insanity with this language is insane. It's unreal. It just works. But it works gooder. One way of avoiding overflow in this example is to change the order of operations. This would now be correct. Number of trees needed. Oh. So instead of dividing area tree by width, or the opposite, just dividing that. Yeah. I guess that works. Well, yeah, because then you would divide it and be like, oh, you have a huge number, and then, oh, okay, that's good to know. I'd recommend you probably don't need this part right now. Okay, cool, thank you. Preventing truncation. What does it say about this? Changing the order of operations may be the solution for truncation as well. Okay, this is not a complete solution. Alright, using floating point type may be another solution. Okay. It's too complicated for what you have learnt by now. I mean, I'm not going to ever need this right away. Well, I'm not going to need this right away, I think. Not that I'm never going to need it, but I'm not going to need it right now. It's kind of like, oh, you have this order of operations, and then... yeah, this order of operations is better than the other ones, and it won't have an overflow. Good God. Gordon, what is this? Okay. Seems too complicated, but okay. We need like a good task to do. Write a program that prints the values of 1 through 10 on a line, on a separate line with a execution value of 7. What the fuck is this shit? Do not use repeated lines in the following as in the following code. Oh. Right, prints the values 1 through 10, each on a separate line with the execution value of 7. So it starts off at 7 or some shit. Instead, you imagine a variable whose value is incremented in loop. You may need to take advantage of the is not equal to operator here. Yes, try it. Okay. Sounds good. Alright, we're gonna go ahead and do this. std.stdio. Let's see. Do the third example? Alright. Write a calculator program that supports the 4 basic arithmetic operations. Have the program let the operation to be selected from the menu. This is a good one, I think. Yeah, let's do that. Have the program let the operation be selected from a menu and apply the operation to the 2 values that are entered. So what criteria do I have besides that? Alright, so then we'll go ahead and do void main that boom scope perfect, and then tab. Let's get our indentation going. Right. Try to see if I can get this knocked out pretty quickly. I think I know what I'm doing enough to get this done. We're gonna do 0, and then 0 is gonna be addition. Addition. 1 is gonna be subtraction. So how many operations should I do? Should I do all of the operations? And then, oh, we should put this in a while loop too, I guess. That'd be a smart idea as well. This is bothering me as well. Just get that done, get that knocked out. Oh god, what'd I do? Middle click, don't do that. While. Then we're gonna do, while true, actually no. We're gonna put our int here. We're gonna put an int in here. We're gonna say, no, put a boolean. No, int. Yeah, int should do. Int exit, then semicolon. While exit is less than or equal to, or less, yeah, just less than 1. So it will always run, and then we'll add a separate line for exit. Actually, we'll just put this as A. Alright, that's good. Then we're gonna change this to write ln, because it's gonna bother me when it just writes on that line. Addition, subtraction, we'll do 2 for multiplication. I'm gonna try to write the best of a calculator that I can. I have an idea which would make it even more of a challenge, but to try to write it so it's not like in so it would reuse the same block kind of, but then just do different operations, which would be kind of weird to do, but like I think it's possible. It's like the main block of code right here we're gonna try to use. Well, it'll make more sense when I get to trying to do it. So 3, we're gonna do division. What's another valuable one to do? Obviously there's all of them are up here. Like you could write out some massive thing, or you could just reuse the same shit over and over and over again. Alrighty, and then of course, yes, we can do increment for 4 and 5 increment and decrement. For inc 5 dec. Then this one's we'll add it in there, why not? So then we'll just add in that. What is this one? Modulus? It's called modulus is what it was called. Oh, what the fuck? Modulus? I don't even know. Don't even know that it. Caret. So this would be 7 for exponent. All right, cool. That's that's gonna be our menu. All right, so then we have to write out a way of figuring out which of those it is gonna be. So obviously that's gonna be the hardest part of this. Well, okay, hold on. So when and then we could write, well, a is less than 9. Right, a is greater than 9. Hold on. Hold on. Well, a does not equal 9. That will be it. We'll just do does not equal 9. And if a is not, well, I don't like using that because it's going to be super specific. I just always am getting them confused. Let's try greater or less than. Greater than or less than. So would it be a is less than 9? This is probably correct, right? Oh god, that's certainly not correct. What the fuck is this? What are we coding HTML at this point? Good god. That should be correct. Okay. Next up, on to our statements. So for the operation, if you choose 0, we need to have a way of placing in 0 in there. So like if 0 is the case, how could we could use a variable to set up our 0, like to have our, you know what I mean? Like kind of like read out like what 0 would be. Or instead of that, we could use this program to reference a separate thing and pull that in and like load it up and be like, oh, here's an addition program. So that way it's not just one giant block of code that's 2,000 if statements long. But anyway, I guess we'll have to do the if method because I'm not really that good at this right now. And I haven't really gotten into file access yet with this. If I had file access, that'd be amazing. Like to learn file access right away. Also, this needs to be put inside of brackets. Which that should be good. Keyword should be good. If... Actually, we need to put a readf. Readf. Parentheses space s. Yeah, that should be good. Then comma. Then we'll do readf, and then if it equals 0. Actually, we could do just a while true. We could do an unconditional statement. See, if we do an unconditional here, it actually would save us. And I'll explain why. Before we do that, though, let's go ahead and int a anyway. See, doing an unconditional there is going to make it easier because I can just put a break. I've never really done that in the past with programming, like when I've programmed in the past or tried to do it. I've never even used unconditionals like this, but because I just like, if you're gonna use a loop, just use a loop. If you're gonna, but it's useful. It makes sense in this case, and then we could just use a break if it's comma number 8 exit. All right, so then we're gonna write out the very shitty and inefficient code that I'm about to write out, but oh yeah, so it read that, and then if 0, then it needs to go into here. Obviously, we should, if we want to make this efficient, we'll do B plus C for everything, or B and C. Oh, but it also depends, because you know, if somebody's a really stupid guy and he decides to use his calculator and he doesn't know that first and second number matter, kind of, then it makes sense to make sure that they know that first and second number matters. We'll just have to, we can either do it slightly efficiently or just terribly inefficiently, but have it more easy to use. I feel like making it easier to use would be the best option. So that's what we're going to do. We're going to make it as easy as possible to use. Let's go ahead and do that. Alright, so if read F, and then it's going to go ahead and A, so that will be our A, which is going to be basically deciding which one it will be. Then don't do that, just do a semicolon. If A equals 0, then code. I'm just going to do a ton of if statements. Well, actually, maybe not. Because you'd have to do else if statements. I mean, you could just do elif statements for this. It'd probably work better. I think that's what I'll do. Put in tons of elif statements. Alright, tab. Then we'll do write ln. We'll make it simple. We'll do A plus B equals sum. Okay, yeah, we'll do that, and then we'll do write ln again, and we'll do this. Write your A space colon space, and then technically you could just do the readf right after them. All right, then we go ahead and do our readf. And this also needs to be int. Actually, we'll do that in the main loop. Int B and int C. So the reason I want to put these in the main loop is so they'll reset after each operation, and they won't just stay the same. Or we could just do B equals A equals 0 and B equals 0, and but that's more lines, and I think it will work this way as well. And it won't have too many implications on the program. Alright, then %s, comma, and then and B. Even though we're writing B to A, it's going to work the same, as long as I remember that that's the case. B, and then B will be written to C. It'll be weird, but it will work. Then we're not going to write a line, we're just going to write. That way it's all on the same line, and this should work. Alright, then next step is to copy that, and then enter, paste, write you B, oh my god, write your B, write your A, and then put that to C, and then we put our semicolon, and then we're going to run. Alright, how is it formatted again? Here's the real question. Oh, it's just variable plus variable. So we'll just do A, or actually let's do B plus C equals, or yes, equals sum. We're gonna put int sum here. Alright, that'd be cool. Int sum, and then semicolon. Then it's good. Alright. But that's backwards, though, because it needs to be sum equals A, or B plus C, semicolon, enter, and that should be addition done. Let's go ahead and check for anything I might have missed in here. Looks good. Control S. We're going to compile for our first test run to see if addition works. We're going to do DMD arithmetic. Ooh, what did I do? I hit enter twice. /arithmetic. Oh. Okay, it reads the first line. Percent not associated with a formula. Oh, shit. Alright, let's try that again. Arithmetic D, and then arithmetic. And now it's gonna work, so I can put in 0 for addition. Write my A, 1 plus 1 equals... Oh, we forgot the part where it writes the fucking sum out. Right. And then actually write ln, and then you would do... No, not even that. Just do write ln and then do sum, and then comma. Or you could actually technically, if you really, really wanted to, put in a wonderful thing called the this is just for making it readable. The sum is comma space just in case. We'll hit Control S and we'll recompile. Oh god. Control C. Why did I put a comma down there? What am I thinking? Oh god, it also needs a comma here. No wonder. No wonder I screwed that shit up. Missed some commas and shit. DMD arithmetic.d. Oh, what the fuck is wrong now? Yes, it's fucking... let me check, just to be sure. What line is that, 18? 18 is this line. Oh, it didn't save. Good God. There we go. Hit 0. Oh, I typed in O and it gave that. Enter. Write your A. 1. 1. The sum is 2. That's just like how the book would probably do it. Very by the book answer to the how to do this problem. Now we're going to do our else if, and then of course enter, enter. And that's going to be copy and paste this whole block right here. After that if statement, copy, Pretty sure you have to define what the parameters are for this as well. So if a equals 2, well then, we're going to test for that. We're going to find out. And we're going to paste this in here. Good God. So if a equals 1, then it will do the subtraction. A minus b equals difference equals diff. And then we'll do minus. And then we're just going to leave sum in there as is. And then we're going to hit Control S just to check it. Even though it shouldn't have any issues, we'll just hit DMD arithmetic, or / arithmetic, do 1. Right, your A, 1, minus 1 is 0. And it still says the sum is, the DIF is 0. In this case, hit Control S. Hopefully I didn't break too much of the code by screwing that shit up right there. Okay, Control C to exit that shit, and then we'll just do another else if a... This is the worst way of doing it, by the way, because I thought you probably could just have some kind of smart system that swaps out what operator you're using, and then you're just really just swapping operators in the middle of the statement. But the question, it's not that easy. I haven't learned enough to be able to swap out an operator in the middle of the statement. That's not where I'm at right now, so. Then if A is that number, we're going to go ahead and create a new one of these. Put in this chunk of code. Copy. And paste it in there. And then we're going to do the multiple. I'm just going to put mult. And then you would do that. B minus C. Oh, okay, that makes sense. And then we would put in one of those. Jolly good. Oh, 3 was division. Well, it's 2, so it's not 3 yet. And then we could just copy this down again. Actually, we'll start from here and we'll just copy and paste that. The copy pasta coding. Copy pasta coding. And then this will be the... What is this? The difference, the dividend. So as in div. Div. And then finally, we'll just do a slash between there. Pretty sure that was division. Could be wrong about that, but it's slash for division, right? Control S. That's like the first 4 of them. Alright, then we have to add an increment, which is going to be different. For an increment, you just take an A. So this is the first case of us needing to have a different one. So we're just going to copy this. Going to go ahead and space that out, paste it in there. And then we're going to do 4 for my A variable, for Control S. And then we'll try out how this is going to work. So you just do A plus, and it will always be +1 equals sum, lowercase sum, well, equals sum, and then of course the sum is boom, and then it will just be B++. B++ equals sum. That looked weird, but I think it would have worked anyway if I kept it there. Alright, that's cool. That means I will now just be able to copy and paste it there to make a -1. one that's going to subtract from it. Copy, space, paste. And then you end up with 400 lines of code, like I said. And this is all else if statements until we get to the break. So then we have that, and then we just have 6, which is modulus 7, exponent, and 8, which is exit. So then we just do b minus minus, put b minus 1 equals, again, diff. The difference is, and boom. And then we'll paste another one. This time we're going to do another a plus b1. So we need to, let me check actually. Oh shit, did I write a bunch of spaces in there? Let's fucking undo that shit. Unneeded spaces in there. Alright, for this one it's exponent. Oh, actually modulus. How many 4s do I have? I need this one to be 5. Next one's gonna be 6. Right? Yeah, that makes sense. These ones have more lines, but when you have 2 numbers to compare, you get more lines, clearly. And of course, put this here, just to close it off. Perfect. Now, this is going to be modulus. So we're just going to type mod. Put mod there too. Mod. Nice. And we'll put in, yes, keep some there. And then we'll put one of those in there. Hopefully it doesn't cause issues, because this is the one I'm kind of nervous about, because that's a scary number right there. Straight up scary number. Scary programming. What am I even doing? And this is not going to be a equals 1. It's going to be, at this point, it's going to be 6 and 7. 6, 7. God damn it. And then we'll have the final else if, which is going to be here, which is 8. It's just going to be a break. Break. Tab, tab, tab. Break. Semicolon. No parameters, nothing needed. It'll just break the program, exit the program, and it'll be perfect. And then we'll have caret, caret for a exponent. Equals exp. Alright, that's perfect. Now that actually is going to be amazing. I think it will work perfectly, as intended. Very much so will it work, I hope. And then of course these are still saying the diff, or the sum. I guess that is technically what it does. It literally increments or decrements. Decrements. Bro, increment and decrement. Greatest shit of all time. Increment and decrement that shit. Bro, straight up. Decrement that number right there. Get that number down. Bro, that number is too high. Needs to be decremented. Good God. That's insanity. We're gonna decrement the number until it's correct. Well, at least we have figured that out. I mean, it would be some technically, because it is just a plus plus. And then it should be good. This is 500 lines of code that 76 isn't Fallout 76 lines of code that you don't need. Good God. And it just works just like Fallout 76. Let's go ahead and give it a test. 0. We already know 0 is going to work. 1. 1 gives you 2. Then of course, oh God, give me the number 1. Right, 1 minus 1 equals 0. 2. 2 times 2 equals 4. Division. 2. Actually, no, 3. 2 divided by 2 equals 1. 4 is increment. We're going to put in 1. It will give me 2. Oh. Actually, what the fuck? Okay, hold on. Well, that's not right, but We can fix that in a second. We'll fix that after we test them. What was it, 5? Write your A. 1. The diff is 1. And it says the sum is 1. But I'm guessing, I'm going to go ahead and make an assumption that the reason it's doing that is because it's not actually... it's a good question. It's a good question why it's not actually doing it correctly. There's a couple of reasons it could be, but we'll figure that out in a second. 6 for modulus. This one's scary because obviously 1, 2, the mod is 1. Okay. It's basically division, okay? Alright, finally we have 7. 2 and 2 should make like 4. Because it's just 2 by the power of 2. If you want to do 64 by 64, it'd give you like something else. 8 by 8 is 64. 32 by 32 is 256. Something like that. Actually, I don't know if that's correct. 64 by 64 is 512 then. If that's the numbers, then. Alright. Next up, we have the final one, which is 8. Back to the cyberbullying station. So it works all the way to the end, except for one of them, which is increment and decrement, because I didn't program those correctly. So let's fix those. Minus, minus. Why would I do... So you would set your sum equals to 1. And then you do minus, minus your sum. That's the idea. And it's written minus, minus variable. Or we could just do minus, minus b. Who has a message for me today? Oh, okay. It is a message for me. Okay. Jolly good. Minus minus b. Plus plus b. Control and S. Compile. We're gonna give it one last dmd.d compile, and then it should be pretty much good to go. We're gonna test increment, and that's about all I'm gonna test before I can go if this works or not. Well, actually, we'll test it. If it doesn't work, we'll fix it. 1 should give me 2, which is good enough for me to say it's done. So the calculator program is pretty much finished. Wow. That's pretty good. But it's 76 lines. So that's the 3rd example done. So if we did the 3rd example, then it's on to the 4th one, it looks like. Because the 4th one was looking interesting to try out. Oh god. This shit's gonna get annoying. There's gonna be like 30 messages, bro. The 3rd one is getting pretty interesting. It'll be pretty interesting to try the 3rd one. Or the 4th one. We already did the 3rd one, but let's go all the way down. Let's see. Write ln. So this is the code they don't want us to write, but what it's saying is write a program that prints the values from 1 to 10, each on a separate line, with the exception of value 7. Oh, that shit's fucking easy. You would just skip 7. I have an idea for how to make this shit really easily. I have a really good idea, but first let's make a new folder for calculator. We'll call it that, and we'll just go ahead and put my hard work into that move there. That's like the most complex shit we've done so far. We'll call this new one numeric discrimination. No caps. No, we'll just call it just number skip 7. Yeah, skip 7, bro. It's like 6, 7, but cooler. It's all the rage nowadays. Skip 7, bro. I'm telling you. I don't even know what 6, 7 means, guys. D. Skip 7.d. Alright, then we get into our coding. Import stdio, and then of course semicolon. Then we're gonna go ahead and hit it with the void main. Bro, hitting it with the void main is a crazy way of saying that shit. Bro, I'm getting good at programming. I spent 700 days learning D. Here's the product of my... Oh god, that's not how that's supposed to fucking look. Maybe I should zoom in a little bit so everybody can see this cringe that we're about to churn out of my factory. I spent 700 days learning D coding language. Here's the product of my sins. 700 days from now, that'll be the video I make. The 700 days of D programming challenge. Good God. Gordon, this is not okay. Int A. So what we're gonna do, we're gonna put the number into A, and if A is something that's not supposed to, if A is 7, we're just gonna fucking skip 7. Sounds easy enough, right? Well, it is literally that easy. So int A, and then we're gonna do while A is less, actually, go back a second. While A, I mean it would work either way, but while A is less than 10, right? That's less than 10. Should be less than 10. I hope to God that's less than 10. I might screw it up and then be like, oh God, it's not giving me my expected result. Then just be like, oh, I could just reverse it. Then that should be everything I will need for that, and then it will be on to the next part. Which is going to be... Ooh, don't do that. But it's going to be the next thing. Figuring out the numbers. Alright, so you would have it increment A plus equals 1. Here's the problem though, if we just do A plus equals 1, I managed to find some really hot and famous Windows user across the globe, but I have only found weirdos and neckbeard Linux users. Especially weirdo Linux YouTubers like me, programming in D. Bro, Linux is the future, guys. I'm telling you all. Linux, all you need is Whoix, bro. Let me pull up my virtual machine with Whoix on it, bro. It's the future. Wow. Whoix workstation. Wow. Not me. Oh, that's good. Qualcomm chips, guys. The Linux cast. Oh God, bro. I was scrolling through. Well, I wasn't scrolling through. I was searching up Linux shit, and then I found like it was like some kind of Linux community or like Road to Linux, bro. Road to Linux, bro. Talk about weird people. Bro, Linux is full of weird people, bro. Good God. Me, I'm just a fish, okay? I'm not a weird guy, I'm just a fish. Don't hurt me. I am just a fish. We're not gonna play that song today. Oh shit, let me get back in my VM. Hit the power button. Shut down. Wow. Whoix is fucking amazing. I like Whoix. But I haven't gotten my Whoix to work yet. Unfortunately, it doesn't connect to the internet, so I can't use a Tor web browser. So, with a plus equals 1... Good grief. You know, I need to create a D program to stop them from sending me messages right now. A plus equals 1. Right, that would be A plus itself. No, wait, what the fuck am I doing? Wouldn't it just be A plus equal? Hold on. Hold on 5 seconds. Let's go ahead and scroll on up to the top. Yeah, like... Hold on. Like if you have number plus equal 20. The same as... Yeah, so it'd be... Oh, okay. Cool. Then you just put a semicolon. Thank God. Thank God for this. Oh my God. Almost screwed that shit up right quick. So A plus equals 1. Go down. Let's see. Then we need to make sure that when it hits 7, it's going to add 1 and skip 7. But every other line is going to be write ln. And we're just going to put A. And we're going to put a semicolon. And then the next step is just to add the if. If A equals 7, but we don't want it to write a line before that. So we're going to say if A equals 6, we're going to add plus 2 and write a line. This will bypass that 7 bullshit. So if A equals 6, we need to put our scope here. Backspace that. Then we add in our wonderful plus... Hold on. A equal... What am I doing? A equals plus 2. Which would basically mean it's 8, and then we do semicolon after that. Write a line. Write ln A... And then we'd go down another, and we just continue from there. So that is how I would do it. Although I don't know if that's the best way of doing it. You could find a way to continue past it. You could be like, oh, if we're at this number, continue, and just ignore it. But the problem is, boom, and then once it hits 10, it will break the loop, hopefully. So we're going to go ahead and compile this. We're going to go into my terminal, which I fucking closed somehow. Okay. Fantabulous. Alright, so we're gonna go into here. Okay, cool. Cool. I see what I'm doing. Alright, we're gonna go ahead and well, actually, you know what? I could show I'm improving my Linux skills as well. Let's go ahead and show off my improving Linux skills. We're gonna go ahead and do cd. And we're going to do the directory, which this is in /desktop/ do this symbol, do a pair of those, and we'll insert in the middle. Insert and then E. Okay, cool, perfect, it will work. My Linux skills are going to improve significantly with this episode. I believe it's D language tools. Yes, I can even see it on the screen. So cd d language tools, enter. Then we're gonna go ahead and do dmd. Then we're gonna run skip 7.d. Oh God. Found when expecting that. Ah, perfect. Alright, cool. Then it will just be that, and it should be... Oh, stop. Stop it. Control S. Control Q. Equals 6. Oh, forgot the equals. This is normal. This is beginner mode. DMD. Okay, then we're gonna just do dot slash skip 7. Oh, actually, dot slash skip 7. 1, 2, 3, 4, 5. It skipped 6, but not 7, bro. What the fuck? And we're gonna have to do, well, a is less than or equal to 10, just so it hits that 10 number perfectly. But at least we know we can just do equals 7 plus 1, and it will skip through fucking 7. Apparently it starts skipping at 5. Completely skipped it. Alright, so let's go ahead and do it now. Let's try DMD skip, and then we'll try skip 7. And we'll still print out 7, but we're getting somewhere. If a equals 7, we're going to add, but then it's also writing the line already. See, that's the problem. So 6, we're going to go ahead and add a second write line in here. So that way it writes the line before and after it adds 2. That way it definitely gets 8. And then to get 10 in there, we're going to, well, a is less than or equal to 10. Then we'll add plus 1. We'll see. We'll figure out the getting 10 to get in there, but I think it should be good after this, except for 10. Oh, but now it adds 11 and doesn't do that. Well, that's pretty weird, but hang on a second. Pretty sure it's as simple as, it's a simple fix, okay? So if we have 6, then it adds... What the fuck is going on that it's adding to that? It's adding to that of an extreme. 1, Control S, and then you'd skip, and then you would... Right? DMD, and then you'd skip 7. I mean, in theory, my idea would have worked, but no. Let's go ahead and try to Control S, and then try it again. DMD skip, and then DMD skip 7. 1, 2, 3. Why is it skipping 2, everyone? Hold on. Why don't I just do A++, bro? Fucking easy. Easiest shit of all time. A++. Plus A. Literally just write plus A and it will add to itself. Doesn't matter. We don't need to worry about A plus equals. Now A plus equals 2 is important there, so we'll do that. Let's try A++. No need to add extra shit like... Let's try plus A. See if that helps it figure its life out. This one doesn't even have a write line after it. Shift enter. Let's try this out. DMD skip 7, writes out all the way up to 12 for some reason. Writes to 12 before it realizes it's writing. Good God. This is not how this is supposed to go. Let's go ahead and reassess the situation. So if 7, don't write a line. Let's try that. So we're just going to do if A equals 7, don't write anything. Don't do anything, don't write anything. Before it can even get to 7, we'll have the write line at the beginning. Copy, backspace, enter, and then paste that shit right at the beginning. Paste it right in there. Boom. Now, after that, so we have our that statement, then function. If it's 7, go ahead and write that out. Or, oh, it does nothing right now. Well, do nothing. Actually, add 1, plus A. Semicolon, and then enter, and then hit Control S. Okay, this should, in theory, be the answer to our problem. Then we go ahead and skip 7, and it writes out 9 2 times, and it writes every number twice. And then we're going to try another method. We're going to try switching back to the A plus equals equation. A plus equals 1, and we'll try an A plus equals 1 here, and then A plus equals 1 there. Because it's just adding itself to itself, I guess. Or, no, not really. That's not how incrementing works. DMD skip 7 and skip 7, and it's a loop. Control C. That's weird as shit. Hold on, because it's just adding A plus equals 1. So I'm guessing that's not actually adding. A plus equals 1. Control S. Where did my terminal go? Oh god, this is terrible. Open terminal here. DMD. What's the fucking shit called? Skip 7.d, and then go ahead and /skip 7, and then it should just run. It just fucking runs out once. Good god. Control C. I'm guessing this is not. It's because it's not plus equals. Do all of them have to be plus equals? A equals the last number plus 1. This is amazing. 1, and then we'll go ahead and go back and go ahead and plus 1, and it should be good. Control S. And then let's go ahead and hit our DMD skip 7.d, and then hit our .skip 7, and it skips 7, but it prints out all the numbers twice. Yet again. Wow. Well, I mean, we're almost there. So why is it adding 2? So A, we initialize it as 0. We write line A after writing line. Oh. That's the problem. So when we do this, we need to have this at the same time. So you can't actually. It's because of order of operations. Okay, so you see, when you have order of operations included, so instead of doing the if statement like this, what we do is if A does not equal 7, print A. Because that, paste, write line A, then we don't need anything else. If A does not equal 7, it will always print A. So it will always take the time to print A because it's a conditional statement. So Control S. And then we'll try it out again. It depends on that condition. And then boom. Writes 1, 2, 3, 4, 5, 6, 8, 9, 10, 11. Now, to prevent it from writing the extra number, I'll go ahead and say, don't add an extra 1 because that's the whole reason it's not running, because it's adding a plus 1. So when we do a DMD skip 7, we go skip 7 all the way. Boom. Look how simple that shit is. Literally the simplest fucking program. All you do is, if A does not equal 7, then boom. Literally the book was telling me the answer from the start, and I just was avoiding that shit straight away. Don't know why I would do that shit. That was dumb. That was straight up dumb. Anyway, I think we'll go ahead and do a little bit more, and then we'll see where we're at for what I need to do today. Alright, so we're going to go ahead and let's not click on the solutions. Let's just continue. I mean, like, what I was going to try to do was not wrong, but it was not the best way. This is quite literally the best way of doing it. So we'll go ahead and put that into the exercises folder. Keep shit organized, you know what I mean? Skip 7, skip 7D, and skip 7.0 go into my, going into my warm-up folder. Since those are pretty good examples of how to do that shit. Alright, let's continue. Floating point types are designed to... Oh, okay. The floats, yeah. Interesting. Adding 0.001 1,000 times is not the same as adding 1. Using logical operators equals and not equals with floating types is erroneous in most cases. Wait, what? So if you're like, oh, well, it equals float. Wait, how does that work? So erroneous, like errorful, bad, something you can't do it? How does that work then? You can use floats like that in Python. Pretty sure you can at least, like float, oh, if my float equals this, then float the boat. Adding, okay, the overflow values are dot infinity and negative dot infinity. The initial value for floating point types is nan, meaning not zero. Nan may be used in expressions or may not be used in expressions in any meaningful way. When used in comparison operations, dot nan is less than nor greater than any value. What does that even mean? Well, I guess less than or not greater than nor greater than. It's just it has zero value. It does not even compare. Can't be compared. Although floating point types are more useful in some cases, they have peculiarities that every programmer must know. Compared to integers, they are very good at avoiding truncation because their main purpose is to support fractional values. Like any other type being based on certain numbers of bits, they are prone to overflow, but compared to integers, the wide range of values that they can support is vast. Additionally, instead of being silent in the case of the overflow, they get special values of positive and negative infinity. Okay. Float 32, you got your float.nan, double.nan, and real.nan. At least 64, maybe more, e.g. 80, depending on egg 80, depending on egg just to make people upset. Egg their house. It's insane. Floating point type properties. Floating point types have more properties than other types. String of is the name of the type. Size of is the length of the type. Dot max is short for maximum, and is the maximum value that the type can have. There are no separate dot maximum properties. All right, let's continue. Min normal, dig dot infinity. Short for digits, and specifies the number of digits that signify the precision of the type. Infinity is so like if you had like 80 bits available, like for that. Okay. Other properties of floating point types are used less commonly. You can see them all of them at properties for the floating type at dlang.org. Wow, look at this shit. Bro, coding. Crazy. I'm crazy, guys. All right. And then we have .nan. Import standard input output. All right. So this is just to show off all the properties. I don't need to know this right now. Specifying floating point values. Floating point values can be built from integer values without a decimal point, like 123 created directly with a decimal point, like 123.0. Floating point values can also be specified with a special floating syntax, as in 1.23 scientific notation forward. So if you want a scientific notation, hey, the E plus part can be read as 10 times the power of 4. Oh god. According to that reading from the previous variable is 1.23. Okay. Continuing onwards, blah, 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 blah. There's too much to read today. But I really want to get into like my first program, but I don't think I'm gonna even really get into that yet. I don't think we're really there. Like, we're still pretty far from that. I feel like first big program. No, we're not getting to that yet. Observations. You'll remember from the previous chapter, the value has 20 digits. That value looks small when compared to even the smallest floating point type. Float can have values of 10 to the 38 range, e.g. 300 and the maximum. How the fuck do you even get to that range then? How does that even work? The maximum value of real is the range of 10 to the... So if you just use float for that shit, then... I mean, you can't even check it really, like... But, like, you could obviously have your game if you program it with floats for some reason. Oh, you have 32 billion of dirt blocks in your inventory. Definitely making fishcraft with this. Truly amazing. Overflow is not ignored. Despite being able to take very large values, floating point types are prone to overflow as well. The floating point types are safer than integer types in this regard because overflow is not ignored. The values that overflow on the positive side become dot infinity, and the values that overflow on the negative side become negative dot infinity. To see this, okay, multiplying by 1 is the same as adding 10%. Let's try reduced. Okay. Going by cutting it in half, then make it to added 10% divided in half is infinity. Okay. Interesting. Precision is a concept that we come across in daily life and do not talk about much. Precision is the number of digits used when specifying a value. For example, when we say that the third of 100 is 33, precision is 2 because 33 has 2 digits. Okay. When the value is specified more precisely as 33.33, the precision has 4 digits. Oh, okay, that makes sense. Just saying that you have more digits, you can use your float as a higher precision. There is no truncation in division, obviously, because it's a float. You divide 3 by 2 and you get 1.5 instead of just getting 1 or 2. Cannot represent all types. We cannot represent certain values in our daily lives in the decimal system that we use daily. The digits for the decimal point represent ones, tens, hundreds, etc. And digits after the decimal point represent tens, hundreds, thousands, etc. If the value is created from the combination of these values, it can be represented exactly. For example, the value is 0.23 consists of 2 tenths and 3 hundredths. It is represented exactly. On the other hand, a value of 1/3 cannot be exactly represented in the decimal system. Wow. A value that cannot be represented exactly in the binary system used by computers is 0.1, as in 10 cents, although this value can be represented exactly in the decimal system. Its binary representation never ends and continuously repeats 4 digits: 0.001100100. Oh god. The following program demonstrates this problem. The value of a variable is being incremented by 0.001 1,000 times in a loop. Because 0.001 cannot be represented exactly, the inaccuracy differs. Okay. Interesting. Oh my god. The same comparison operators. This shit keeps going on. Unorderedness. The same comparison operators that we have covered with integers are used with floating point types as well. However, since the special value .nan represents invalid floating point values, comparing nan to other values is not meaningful. For example, it does not make sense to ask whether nan is 1 or greater. For that reason, floating point values introduce another comparison concept, unorderedness. Being unordered means that at least one of the values is .nan. The following lists all of the floating point. Oh, so like it could be any value could be .nan. It's like meaningfulness with nan, so equals and does not equal, but anything like with greater or less than does not matter. Okay, cool. Exercises. So instead of float, use double or real in the program above. Okay. Modify the calculator from the previous chapter to support floating point types. The new calculator should work more accurately with that change than when trying the calculator. You can enter floating point values in various formats, as in 1000, 1.23, 1.23 E4. Interesting. We might try that out. Write a program that reads 5 floating point values from the input. Make the first print twice, and each value then 1/5 of each value. It's confusing me, but okay. I mean, I don't think it'd be hard to change the calculator to floats. I feel like that'd be pretty easy. The problem is we'd have to integrate it correctly with the weird shit like division, but who knows. Arrays! This is important. Arrays are like the most important shit in programming, bro. Like lists. You need an array or a list or some shit. But I think we're going to leave here. So how far did we get in the book, actually? I want to actually check, just to check my progression. Check my... No, cancel. Check my progress. Wow. Far out, man. Oh, man. Oh, dang it. Let's check my progress so I can exit and save and be done for today. Well, till later. I might do more later. Who knows? We'll figure it out. I got plenty of time today. Got too much time today. Bro, what am I doing? Wow. Let's go ahead and just check. Main page. So I've made it that far. Oh, Turkish. They must use tur and... I mean, they must use tur, but they must use D in that country. Programming in D. Wow. We've made it to arrays, but we haven't even made it. Good God. The amount of shit you have to learn. Wow. Wow, look how fucking intense this is, man. The learning process is fucking huge. But we've gotten to arrays, which I'm excited about because that means we'll be able to play with arrays next stream, which should be later. So, I mean, if I have time later, we'll see what I'm up to. But I'd like to thank you all for watching. I'll see you all next time, and this is what we have to look forward to in the next section. So I'm gonna bookmark this, and